Good day, everyone. You are welcome to my YouTube channel, Everything Medical. So, in today's class, we'll be treating metabolic biochemistry, precisely digestion of carbohydrates. And here are my outline. We have digestion in the mouth, action of ptyalin, digestion in the stomach, digestion in the duodenum, action of pancreatic amylase, digestion in the small intestine, actions of intestinal juices, where we have the sucrase, lactase, maltase, aromatase, and intestinal amylase. So now, before we dive into the digestion of carbohydrates, first of all, you have to note that the dietary carbohydrates that we eat principally contains mostly contains polysaccharide, which are what? The starch and the glycogen, and it contains moderate amount of what? Disaccharide, which are sucrose and lactose and maltose. Now it contains little quantity of monosaccharide. Do you get? Now, one thing you should know again is that when we come to the digestion of carbohydrates in the mouth, why does carbohydrate digest in the mouth? It tends to digest in the mouth because there is a presence of carbohydrate splitting enzyme called ptyalin. It's called what? Ptyalin. Ptyalin is a carbohydrate splitting enzyme, and we have it like this. We have glycogen, we have starch, and we have dextrin. Here is how it goes. We have maltose, we have maltoses, and we have glucose. Now, what is the work of ptyalin? Ptyalin belongs to alpha amylase group of an enzyme. So it tends to, there are those enzymes that act on only carbohydrates. Now here we have alpha amylase. Now, as you can see that mostly the carbohydrate that we eat in our diet comes firstly as polysaccharide before disaccharide and monosaccharide. So now, what is the essence of me saying that it contains polysaccharide? Because almost the diet we eat in a carbohydrate form comes as a polysaccharide. Now, it has a moderate quantity of a polysaccharide and a minimum quantity of monosaccharide. Now, this is how it works. Now, we have established earlier that why carbohydrate digest in the mouth is that the mouth contains a saliva, and that saliva is a fluid that houses an enzyme that breaks down those carbohydrates. Now, those enzymes are what? It is ptyalin. We call it alpha salivary amylase or ptyalin. Why is it called alpha salivary amylase? Is because it belongs to amylase group of an enzyme. Do you get? So that is why it is that way. As you can see here, almost these carb molecules are polysaccharide, and these ones are what? Are disaccharide and what? Are monosaccharide as well. So that is how the action of ptyalin tends to work in the mouth, which is being found in the saliva. Do you get? Now, recall that when you eat a carbohydrate, those carbohydrates will be mixed up with the saliva in the mouth, and once they are being mixed up, they will get what? Masticated. But the type of carbohydrate food that get masticated in the mouth are solid carbohydrate food. We have solid carbohydrate food and liquid carbohydrate food. Solid carb and what? Liquid carb. Now, solid carb tends to be masticated in the mouth because it is a solid food before it will enter the GIT proper. Now, but liquid carbohydrates escape mastication in the mouth, because you can't tell me that you will masticate a liquid food such as milk. Milk is a carbohydrate. Do you get? So you can't chew milk. Do you get? So it will escape mastication in the mouth. Now, going to other chambers of the GIT in which carb is digested. So that is how the goes. Now, that is all about the digestion of carbohydrates in the mouth. Now we go to the action of ptyalin. We have established earlier that ptyalin belongs to alpha amylase group of an enzyme. So it can be called alpha salivary amylase. You get? Now, why does carb digest in the mouth? Because the mouth contains a saliva, and the saliva contains a principal carbohydrate splitting enzyme called tartalin. So had it been there is no tartalin in the saliva, there wouldn't have been existence of digestion of carbohydrates in the mouth, because the mouth will not be able to have that carbohydrate splitting enzyme called the tartalin. Do you get? Now, tartalin as an enzyme is being activated by a chlorine ion molecule, and it has a pH. It has a pH which is what? 6.7 pH. This is the pH range of tartalin in the saliva. And recall that once those foods get mixed up with saliva, they tend to as well follow through the esophagus to the stomach. So once they get to the stomach, the pH of tartalin falls to 3.0 pH. This is the pH of tartalin in the mouth, in the stomach. So once it falls to 3.0, it means that the activity of tartalin in the stomach will fall, because enzymes are pH dependent. They work with pH. Do you get? So once it gets to the stomach, the pH drops to 3.0, which means its activity will not be able to perform effectively in the stomach. That is how they work. Now, what is the action of tartalin in polysaccharide? Look at it here. Look at the group of the enzyme they belong to. Alpha amylase group of an enzyme. Tartalin tends to catalyze the hydrolysis of alpha 1,4 glycosidic linkage of polysaccharide. It does what? It catalyzes the alpha 1,4 glycosidic linkage, or alpha 1,4 glycosidic linkage. So this is what tartalin does in polysaccharide. Now, that is all about what? Tartalin. Let's go to the stomach. Let's move to the stomach. Here we are in the stomach. Now, in stomach, the gastric juice, which contains the gastric enzyme, does not have any enzyme that catalyze or break down carbohydrate. So there is no true digestion of carbohydrates in the stomach, because the stomach lacks an amylolytic enzyme. So in stomach, there is no carb digestion. But then HCl, which is hydrochloric acid, tends to behave like an enzyme, because example, sucrose could be hydrolyzed by HCl to give 2 carbohydrate moiety, which is glucose plus fructose. Now look at the 2 carb moiety, but then that does not mean that there is a digestion of carbohydrates in the stomach, because HCl is not an enzyme. It is not an amylolytic enzyme, and it is not a carbohydrate splitting enzyme. That is why there is no digestion of carbohydrates in the stomach. Do you get? But then HCl tends to break some disaccharide, which is what? Sucrose, to form 2 glucose moiety, 2 carbohydrate moiety, which is glucose and what? Fructose. Do you get? Now let's move to the duodenum. In duodenum, those food bolus from the stomach enters the duodenum. The duodenum is the first part of the small intestine. Do you get? So once they enters the duodenum by the opening of the pyloric orifice, so it enters the duodenum, and the duodenum contains the pancreatic juice. Now, what is the content of the pancreatic juice that tends to digest carbohydrates? It is the enzyme called pancreatic amylase, or amylopsin. So it is the content of the pancreatic juice called the pancreatic amylase that tends to digest carbohydrates in the duodenum, because there is a communication between the duodenum and the pancreas through the what? Through the ampulla of Vata and the accessory duct of Santorini. Those are the two openings that empty the pancreatic juice to the what? To the duodenum. And recall that the pancreatic juice contains three classes of an enzyme. It contains proteolytic enzyme for protein. It contains lipolytic enzyme for lipid. It contains amylolytic enzyme for carb. Now, what is the amylolytic enzyme that is found in the pancreatic juice that tends to digest those carbohydrates in the duodenum? It is the what? The pancreatic amylase. The what? Pancreatic amylase, called amylopsin. That is its alternative name. Now, let's go to the action of pancreatic amylase. Action of pancreatic amylase. Now, pancreatic amylase, as we have established earlier, that it is an amylolytic enzyme. It belongs to alpha amylase group of an enzyme. It is similar to ptyalin because two of them belongs to one class of an enzyme. Now, this pancreatic amylase digests carbohydrates as well, the carbohydrates that are found in the duodenum. Now, the pancreatic amylase is as well being activated by a chlorine ion molecule, same as the one that activates the ptyalin in the saliva. It has a pH of 7.4. It has a pH of what? 7.4. While the ptyalin has a pH of 6.7. Now, this pancreatic amylase, it catalyzes the hydrolysis of alpha-1,4 glycosidic linkage of the polysaccharide. So the only difference between ptyalin and pancreatic amylase is that ptyalin is found in the saliva, while pancreatic amylase is found in the pancreatic juice. And ptyalin has a pH of 6.7, while the pancreatic amylase has a pH of what? 7.4. So, and that is only the difference between them, where they are being found, which is their site, and the variations in their pH levels. Now, let's go to the digestion in the small intestine. The small intestine, to be precise, is the ileum. Is the what? Is the ileum. So now we'll be going to the digestion in the small intestine. In the small intestine, we have the intestinal juices. The intestinal juice contains the intestinal enzymes. It contains the what? Intestinal enzyme that tends to break down those disaccharide into monosaccharide. What is the first enzyme that could be found in intestinal juice? We have the sucrase. Now, this sucrase is an enzyme that catalyzes the what? The hydrolysis of sucrose. Sucrose is the cane sugar. Now we have sucrose will give us two carbohydrate moiety, where we have the fructose and glucose. These are the two carbohydrate moiety or two carbohydrate quantities that will be derived from sucrose by the activities of what enzyme, which is sucrase enzyme. Recall that for a carbohydrate to yield its derivative, there will be an addition of water. That is the essence of the hydrolysis. Water is involved, so we add our what? Water. So these are the two carbohydrate moiety that was yielded on the hydrolysis of sucrose by the sucrase enzyme. That is it. Now let's move to other one. We'll move to lactase. We have lactose. Lactose, when hydrolyzed, will give us what? Galactose plus glucose. So these are the two carbohydrate moiety that will be used when lactose is being hydrolyzed by a lactase enzyme. Lactose is a mixed sugar. Now we have lactase. Recall that there is an addition of water. So add our water, which is H2O. Bear it in mind. You have to know this word derivative. You could recall what you did on your biochemistry, on the chemistry of biomolecules. Now, what is the concept of carbohydrate? A carbohydrate is a polyhydroxy or aldehyde group that yield its derivative on hydrolysis. Do you get? So there is always addition of water for a carb to yield its derivative. That is the essence of me writing these H2O molecules. Now let's go to our next enzyme. So where we have maltase. So we have maltose. Maltose will give us 2 glucose molecule, where we have glucose plus glucose. These are the 2 carbohydrate moiety that will be used when there is hydrolysis of maltose by a maltase enzyme. Recall that there is what? An addition of water. Now, maltose is a what? Is a malt sugar. This is a cane sugar. Cane sugar. This is a milk sugar. This is a what? A malt sugar. So this is how they are being derived. Now, let's move over to the second to the last. We have the isomaltase. Now, you have number 4, isomaltose. Isomaltose will yield glucose plus maltose. Now, the difference between maltose and isomaltose is that isomaltose have alpha 1,6 glycosidic linkage, while maltose have alpha 1,4 what? Glycosidic linkage, and they have different enzyme. Now we have here isomaltase. Do you get? And they use different carbohydrate moiety. So this one, it has a branching chain. Do you get? So this isomaltase, it catalyzes the hydrolysis of what? Alpha 1,6 glycosidic linkage by splitting alpha dextrin limit on its branching chain to produce what? Glucose and maltose. So know that difference. Know that different very, very well. Now let's go to the last one. We have what? Intestinal amylase. Intestinal amylase behave the same action with ptyalin and pancreatic amylase, because those are the key carbohydrate splitting enzymes that are found on the different chambers of the GIT. Do you get? One is the one found in the mouth, in the saliva, which is the what? Ptyalin. Now the second is the one found in the pancreatic juice called pancreatic amylase or what? Amylopsin. While the last one is the one found in the what? Intestinal juice, precisely the what? Intestinal amylase. Do you get? Now what is the work of the intestinal amylase? Intestinal amylase, what does it do? It tends to break the what? It breaks or it catalyzes the hydrolysis of terminal alpha 1,4 what? Glycosidic linkage between polysaccharide and what? Oligosaccharide. So you have to know the actions of these key enzymes. Recall that there is no digestion of what? Carbohydrate in the stomach, because it lacks what? A key or a carbohydrate splitting enzyme. Do you get? So bear it in mind. Where carb digest is in the mouth, is in the duodenum and the what? The small intestine, precisely the ileum. Do you get? Because the small intestines are partitioned, which is the first part, the duodenum, the second part, the jejunum, and the last part, the ileum. The ileum is the biggest part. So on my next class, I will discuss the what? The absorption of carbohydrates. I'll discuss the word absorption of carbohydrates. Do you get? So subscribe to my YouTube channel and wait for my next class. Thank you so much for watching.